In this video, we're going to be going over function notation, and this is our part 4 video inside of Math 20-1. So basically first, we're going to go over the definition and how to actually do function notation, and then afterwards, we're going to go over a few example problems to further enhance our understanding. So let's get started with this video. So starting off with what is actually function notation. So basically when writing the equation or rule for a function, we can actually use function notation instead. And this is an example over here of how function notation looks like. So now we're going to go over step by step of how to actually write this function notation. So starting off, first what we're going to do is name of the function. So if we look here in this picture, we can see the name of the function is in the beginning, and in this case it's just f. So the name of the function is f. For the second part, we have to have our input variable. So in this case, our input variable is going to be x, and it's inside of these parentheses. And then for the third step, we have the equation or rule that connects the independent and the dependent variables. So in this case, then we have our equation or rule, and that's what the function is going to be equal to, and this is also what connects our independent and dependent variables. And also when we read function notation, whenever we see fx like this, we say f of x. So in this case, f of x would be equal to 3x squared plus 1. So now since we know a little bit about function notation, let's go over some example problems to further enhance our understanding about this topic. So for example number 1, a cab company charges riders $2 for a ride plus $1.50 for every single mile traveled. So in order to create a function for this, so what we need to do now is just write an equation for this. So the equation is going to look like this. So cost x is equal to 1.5x plus 2. So in this case, the function name is cost, our input variable is x, and our equation is 1.5x plus 2. And the reason why we're putting 1.5x plus 2 is because we can see that the cab company charges $2 for every ride. So $2 is the fixed number, so that's why we have it as our constant. And then it also says plus $1.50 for every mile traveled. So every single mile traveled, which is represented by x, we have to charge an additional 1.50. So that's why this is the equation. So function or cost x is equal to 1.5x plus 2, and where x is the number of miles. So also some common names for functions include the letters f, g, and h, but we can call functions with a variety of different names. Like in this case, we used cost, and there's many different ways that you can name a function. So now we're going to talk about substitution using function notation. So and the question that we're given here is, given that g of x is equal to minus x plus 1 squared, evaluate the following. So all we need to do is just evaluate the following. So for the first one, what would the answer be if the input x would be equal to 1? So in order to do this, let's go step by step. So first of all, we have to rewrite the whole entire formula. So g of 1, we're going to write that here on the left side, is equal to minus, and then we're going to replace this x here with 1 since we're given that x is equal to 1. So we're replacing this x with 1, and then we're going to keep the 1 plus 1, and then we're going to have it squared. So now if we simplify this, then 1 plus 1 is 2, and then basically what we do next is just square. So 2 squared is 4, and then the minus is already there, so our answer is minus 4. So for this first answer, g of 1 is equal to minus 4. And for the second one, we have g and then of 3a. So instead, this time, instead of replacing it with 1, we're going to replace it with 3a. So let's go step by step. So g of 3a is equal to minus, and then we're replacing x with 3a plus 1, and then squared again. So if we simplify inside the brackets, and we square everything, then we're going to have minus 9a squared plus 6a plus 1. And then if we distribute this negative to all of them, then we're going to get our final answer as minus 9a squared minus 6a minus 1. And that is the final answer for this second part of the question. So now for question number 3, given that f of x is represented by the following graph, evaluate each of the following. So for the first question, we have when x is equal to 2, so f minus 2. So in order to do this, all we do is look at the x-axis, and we look at when it is minus 2. So when it's minus 2, which would be right here, we can see that y would be equal to 1. So in this case, the answer of when f is minus 2, we have is equal to 1. And for the second part, we have f is 0. So same thing, we look at the x-axis and look at when x is 0. So x is 0 here, and we can see that it's still 1. So basically f of 0 is also equal to 1. So in this case, you can also use function notation in order to look through a graph and also get the same type of answers. And that summarizes question number 3. And that's also it for the first part of this function video. So thank you so much for watching from Try to Be Useful. And in our next video, we're going to be going over some more practice problems for function notation.